Welcome back everyone. In today's session we are going to solve question number 7 and 8 of first exercise. Yesterday we have done questions in which we proved that the points form a square, which was about this figure Champa and Chambeli. So Champa was correct in that case, and I gave you the properties of quadrilaterals and also the properties of triangles. So you have to, I even said you to try question number 6. Check which type of quadrilateral is formed with the given points. Okay, with these points, which type of quadrilaterals are formed. 3 bits are given. I explained you the concept, so try that if you have not done, and if you have any doubt, get back to me. Okay, now today we are going to see question number 7. In question number 7 you can see, find the point on the x-axis which is equidistant from 2, -5 and -2, 9. So he is asking you to find a point on x-axis. So if I draw the coordinate axis, that is x-axis, and the y-axis, okay, you know, this chapter is continued in your higher classes, even in intermediate, first year and second year. This is not the end of coordinate geometry. This is very vast topic. You will have chapters named like straight lines, pair of straight lines. Many chapters are there in intermediate, first year and second year, about related to coordinate geometry. So these are the basics which you are learning here. Okay, fine. So I have drawn x and y axis. This is your x axis, this is your y axis. Now he is asking you, just have a look at the question. Find the point on the x-axis which is equidistant from 2, -5 and -2, 9. So equidistant, we have to find a point on x-axis. Now how will be a point on x-axis? Point on x-axis will be of the form x, 0. Okay, x, 0, or you can say a, 0, that doesn't matter. Okay, so there is a point on x-axis. This point is equidistant, means at equal distance from 2 points. These 2 points are given to us. Okay, just roughly I'm showing you the figure. These 2 points are given to us. I'll name it as say P and Q, and this is R, suppose. So I can say that P and Q are equidistant from R. Excuse me. Point P and Q are equidistant from R, means at equal distance. When you measure the distance from P to R and from Q to R, both are equal. That is the meaning of equidistant. Okay, just I am explaining you the meaning of equidistant. Okay, another example if I give you of equidistant, like there is one student A at some point here, and there are 2 students standing 5 meter and 5 meter away from this. Okay, his two friends are standing, that is B and C are standing at a distance of 5 meter each from A. I can say that B and C are equidistant from A. Okay, B and C are equidistant from A. So I can say distance AB is equal to distance AC in this case. Okay, this is the meaning of equidistant. So going back to the question now, so we have to find the point on the x-axis which is equidistant from these 2 points. So for your reference I am giving you an example of graph which shows the point on x-axis. So this is the point on x-axis, you can see it is 2, 0. So any point on x-axis will be of the form x, 0. You have studied this in 9th class. Okay, this can be x, it can be any other alphabet, and any point on y-axis will be of the form 0, y. If it is mentioned y-axis here, then I can take 0, y. So now we have to find a point on x-axis which is equidistant from x, 0. Okay, let's begin the problem now. This is your question again. So I'll take, let the given points as P and Q, and the point required be are A, 0. Why A, 0? Because it is a point on x-axis. You can even take x, 0 or A, 0, that doesn't matter. So I have taken the point as A, 0. R is equidistant from P and Q. Okay, so as per our question, R is equidistant from P and Q, like I showed you just now here. Okay, this is your R which is equidistant from, I'll erase this because I have taken R as A, 0. This R is equidistant from P and Q. So what can I write? I can write PR is equals to QR, isn't it? As R is equidistant from P and Q, I can write PR is equals to QR. The distance PR will be equals to distance QR. Hence PR is equals to QR. Now I'll find the distances PR and QR. So PR, I'll take the point P, that is 2, -5. This will be your x1, y1, and R A, 0, that will be your x2 and y2. Okay, because we are applying the distance formula now. So x1, y1, x1 is 2, y1 is -5, and x2, y2, A, 0. Substituting this in the formula, what is the distance formula? x2 minus x1 whole square plus y2 minus y1 whole square. So x2 minus x1, A minus 2 whole square, and 0 minus of minus, that is plus 5 whole square. A minus 2 whole square can be expanded by using A minus B whole square formula. So A square plus B square minus 2AB plus 5 square is 25, and still if you expand it, you get A square plus 4. Okay, 2 square becomes 4, and this is 4A plus 25, and finally we get A square minus 4A. 4 plus 25 becomes 29. Okay, so this is PR. We found the distance PR. This distance I found. Now we have to find distance QR. Okay, so for finding distance QR, again I'll apply the same formula. I'll take Q and R here. Okay, X Q, what is your x1, y1? Minus 2 and 9, that is from Q. This is your x1 and y1. Okay, and x2, y2, R. Okay, we get x2, y2 from R. So x1, y1 is minus 2, 9, and x2, y2 is A, 0 again. I'll find the distance x2 minus x1 whole square. Here again I apply the formula. So this becomes x2 minus x1, A minus of minus 2, because formula minus and that minus becomes plus, and 0 minus 9 whole square. Applying A plus B whole square here, A square plus B square plus 2AB. So A square plus 2 square plus 2 into A. 9 square is 81. Okay, we finally we get this. These two, this is PR and this is QR, at the points, as the points are equidistant from R, P and Q are equidistant from R, I'll equate these distances PR and QR because they are equidistant. Okay, so I'll equate these two distances which I have got here. So from the question, PR is equals to QR, equating both the distances which we have got. Now how to remove the square root? We'll do squaring on both sides. The square and root gets cancelled here and here, and finally we get a square minus 4a plus 29, a square plus 4a plus 85. Okay, I have taken these two. Okay, this last steps I have taken and I'm equating them. So a square, now I'll transpose all these terms to the left. So I'll get a square minus 4a minus a square minus 4a, and numbers I'm keeping on the right. Okay, or you can cancel a square directly. Anyway, you can try this, nothing, no problem. Okay, a square minus a square gets cancelled. Minus 8a is equals to 56. A is equals to 56 by 8 comes in the denominator. 8 sevens are 56. Finally, we have got the value of a, that is a is minus 7. Finally, the point on x-axis is minus 7 comma 0. Okay, so this is the point minus 7 comma 0 from which they are equidistant. P and Q are equidistant from minus 7 comma 0, and this point lies on x-axis. Hope it's clear to you all. Okay, now let's go to the next. Now in this question, he is asking you to find the value of y for which the distance between the points 2 comma minus 3 and q 10 comma y is 10 units. So this is a different type of question. Till now we were finding the distance between the points, but here distance is already given. He is telling the distance between this P and Q. There are 2 points P and Q. The distance between these 2 points is given to directly. Okay, it's 10 units. We have to find that missing value, that is the y value in the coordinates Q. So let's see how to do this. Here also we'll apply distance formula. Let the points be PQ. PQ is equals to 10 units. So we'll apply the distance formula. So from P I'll take x1, y1, and this Q will give you x2 and y2, 10 comma y. Okay, x2 is 10 and y2 is y, and the formula is here. So let's apply the formula. X2 minus x1, 10 minus 2 whole square, and y2 minus y1, y minus of minus 3, that is y plus 3 whole square. Okay, this is equal to 10 units because distance is already given to us. Okay, distance is already given to us as 10 units. So we are going to find the value of y. So this is equal to 10 units. Now I'll expand this and try to find the value of y. 10 square becomes squaring on both the sides to remove the square root. Okay, I'll do squaring on both the sides because I need to remove this square root. So square and root gets cancelled here. Finally remains what? 10 square, 8 square plus y plus 3 whole square. 10 square is 100, y plus 8 square is 64, and this is y plus 3 whole square as it is. Okay, now what can I do in this is I can shift y plus 64 to the right. We'll do it by different method. Okay, I'm deleting this method. I'll explain you by another method. So y plus 3 whole square is equals to 100 minus 64 I'll write, okay. 100 minus 64, so 100 minus 64 is 36. So y plus 3 whole square is equal to 36. I can directly remove, okay, instead of expanding, you can even do by expanding. Instead of expanding it by a plus b whole square, I am directly simplifying it, okay. Y plus 3, the square is removed and we get a root here, okay, and y plus 3 is equal to root 36 is plus or minus 6. 36 can be plus or minus 6. Y plus 3 is equals to 6, or y plus 3 is equals to minus 6. Y is equals to 6 minus 3, 3, or y is equals to minus 6 minus 3 becomes minus 9. So these are the two values of y which are possible. This is one way of doing without expanding, okay. Another method of doing is by expanding. You can do it by expanding also, but there you need to factorize, okay. To avoid that, to save your time, you can do it in this way. So this is the way we solve these two questions, and these two are most important questions of this exercise. Hope the concept is